Factorizing, or finding the factors of a quadratic expression, is the opposite of expanding brackets and is used to solve quadratic equations. We will just look at factorization of the expression at this stage. All quadratics are of the form ax squared plus bx plus c. Okay, so this is the general form of a quadratic expression. So how to factorize a quadratic or the quadratic expression when the constant in front of the squared term is equal to 1. So the first step is to write out the factor pairs of the last number, which is usually a constant, labeled C. The second step is to find a pair of factors, P and Q, that when you add them, it gives the middle number, B, and when you multiply those two numbers, they give you the last number, C. So to mathematically express what I've just said, so x squared plus bx plus c is equal to x squared plus p plus q times x plus p multiplied by q. The third step is to write two brackets and put the variable at the start of each one. And finally, the fourth step is write one factor in the first bracket and then the other factor in the second bracket. The order isn't important, but the signs of the factors are. Okay? So let's look at some examples. So example 8.01, factorize x squared plus 8x plus 15. So notice that in the given expression, there is nothing common in all three terms. Right? All three terms. There is an x squared term here. We have 8x plus 15. Also note that there is this quadratic expression as it has an x squared term. So any expression that has an x squared term, that means it is a quadratic equation or expression. So the first step is we need to find the factors of 15. So the factors of 15 are 1, 3, 5, and 15. The second step, the pair which when added together that gives the middle number is P equals 5 and Q equals 5. Notice here, no other two numbers when added or subtracted gives us the middle number, which is 8. The only two numbers that give us 8 is 3 and 5. So we're at P plus Q is equal to 3 plus 5, which equals to 8. Also notice that these two numbers, when we multiply them together, 3 multiplied by 5 gives us the constant number at the end, which is 15. Okay. The third step is we open two empty brackets and we put the values for P and Q inside the brackets, and that is our factorization complete. Okay. Also notice that if we were to multiply this out again, so if we did as we did expanding double brackets in the previous chapters, so if we did x multiplied by x gives us x squared, x multiplied by 5 gives us 5x, 3 multiplied by x gives us 3x, 3 multiplied by 5 gives us 15. Therefore, x squared plus 5x plus 3x equals 8x plus 15. We get what we started off with. Okay, so it is always a good check to multiply the double brackets once you have the answers. Once you put the factors inside, multiply out the brackets just to see if you get what you started off with. Okay, it is always a good practice. Okay, so example 8.02, factorize x squared minus 11x plus 24. So notice that in the given expression here, there is nothing common in all three terms. Also note that this is a quadratic expression, as it has an x squared term at the front. Okay, so now let's do what we did before. Okay, there we go. First step is we need to find the factors of 24. So the factors of 24 are 1, 2, 3, 4, 6, 8, 12, and 24. Okay. The pair which when subtracted together, it is a pair that when subtracted together, that gives the middle number, which is 11, is p equals minus 3 and q equals minus 8. Why subtracted? Because this number here is negative 11. Okay, so we can see that 8 and 3, 8 minus 3 minus 8 gives us 11. You might be tempted to, or you might also notice that 1 minus 12 also equals minus 11. But notice that if you were to multiply 1 and 12, or 1 positive 1 and minus 12, you don't get positive 24, you get minus 12. Okay, so that we can't use that. But minus 3 multiplied by minus 4 gives us positive 24. Okay, so notice here, so our P is minus 3, our Q is minus 8, therefore minus 3 minus 8 is equal to minus 11, minus 3 times minus 8 is equal to positive 24. This is what we have. So we open two brackets up and then we substitute in our values for P and Q. Now to check again, to make our final check, just to see, does it give us the original expression? So x squared, x times x equals x squared, x times minus 8 is minus 8x, minus 3 times x equals minus 3, minus 8 times minus 8 equals positive 24. Therefore, if we simplify, collect all the terms, we get x squared minus 11x plus 24, which is indeed what we started off with. Okay, so always do this check at the end. Okay, so let's look at another example. So example 8.03. We are asked to factorize x squared minus 36. Now we notice that in this case, we don't have a middle term, but we know that it is still a quadratic equation because the first term, expression, my apologies, quadratic expression, because the first term has a squared component to it. So we can rewrite it in the form that you've seen previously. So we can rewrite the expression as x squared plus 0x minus 36, then follow the same steps as before. So we need to find two numbers that when we times them together gives us minus 36, and when we add them together gives us 0. So let's find out all the factors of 36. So we get 1, 2, 3, 4, 6, 9, 12, 18, and 36. So we want two numbers when we add them together, or add and subtract them together, gives us the middle term, which is 0. And when multiplied together, gives us negative 36. And those two numbers are 6. Well, just 6 on its own this here. So we have, if we set P equals 6 and Q equals minus 6, we get 6 plus minus 6 equals 0. And we have 6 multiplied by negative 6 equals minus 36. So we put it into the double brackets. x plus 6 and x minus 6. And then if we want to verify, let's multiply this out. We have x squared minus 6x plus 6x minus 36, which is indeed what we have here. Okay, which will be, so the negative 6x and the positive 6x will cancel each other out, leaving us with what we started off with. Now, a useful formula to remember at this point is the formula that you see here. Okay, the formula for perfect squares. So we could have also used this formula and saved us some of the calculations here. So straight away, if we notice that 36 is a perfect square, we could write it as 6 squared. Then we can, and both terms, if we can see that both terms are squared, then immediately, as you notice here, x squared minus 36 equals x squared minus 6 squared, which straight away using this formula, x plus 6, x minus 6 can be written in this form. Okay, so this is a very useful formula to remember. So look out for expressions when you're dealing with quadratics and see if they are perfect squares. So you can utilize this formula. Okay. Example 8.04. We are asked to factorize 100m squared minus 49b squared. Okay. Now we know that this is definitely a quadratic expression because of the squared term. It doesn't have to be x. Okay, in this case, a different letter is used and m is used. So notice here, both are square expressions with a negative in the middle. So we square root each term, then put into brackets where one is a positive in the middle and the other with a negative in the middle. Okay, so notice that straight away we can write down 100m squared equals 10m multiplied by 10m. We could rewrite this 49 because if we know our times tables, we could write it as 7b times 7b. So using the formula where x is equal to 10m and a is equal to 7b, so this is the formula that I was referring to, we can rewrite this expression as 100m squared minus 49b squared, which can be written as 10m squared minus 7b all squared, which can be expanded on. Okay, the square would go outside, then you'll have double brackets. And if you were to, skip forward there. So if we were to multiply out these brackets again, you get, you'd see that we get what we started off with. Okay, so it's a very useful formula to remember. So definitely look out for these types of quadratic equations and expressions where we can utilize this formula. Okay, it will save us a lot of calculations. Now it's your turn to have a go at these questions and see how you get on. So we have seen in the previous examples how to factorize when the first constant term associated with the first term, the x squared term, was equal to 1. So what about when it's not equal to 1? Okay, so what if the x squared had another number in front of it? Okay, how do we deal with the equation in this case, or an expression? But in this case, it will be an equation as we have an equal sign. All this time we were looking at expressions because they didn't have an equal sign. Okay, so we're going to look at two methods of dealing with quadratic equations where the a is not equal to 1. So this is method 1. So method 1, the first step is we're going to multiply the end numbers together, the a and the c. Okay, so both ends. This is the first end, and the I was going to say end, but the last number and the first number. Then write out the factor pairs of this new number in order. The second step is we need a pair of factors that add to give the middle number and multiply to give this new number. The third step is rewrite the original expression, this time splitting the middle term into the two factors we found in step 2. The order of these factors doesn't matter, but the signs do. Okay. The fourth step is split the equation down the middle and fully factorize each half. The expressions in the middle, in the brackets, must be the same. And finally, the fifth step is factorize the whole expression by bringing the contents of the bracket to the front and writing the two other terms in the other bracket. Okay, so it's a lot of words here, sounds very complicated, but in actual application, it is not complicated at all. Okay, so let's look at some examples. So example 8.05, we have factorize the following quadratic equation. 2x squared plus 5x plus 2 equals 0. So the first step is we need to find the factors of the first term, first constant, multiplied by the last constant, the last number, so a and c. So that's 2 times 2, which equals 4. Therefore, the factors of 4 are 1, 2, and 4. The second step is the two factors that we need to find two factors that add to give us the value of b, which is equal to 5. Okay, so here we notice that 1 and 4 will give us the value 5. If you were to add 1 and 4 together, give us 5. The third step is rewrite out the expressions, the terms. So we have 2x squared, 1x plus 4x plus 2. Then we put brackets around. So we collect the first two terms and the second two terms, and we put them in brackets. Okay. And then what we do is we factorize a common, we take a factor out of the bracket. So a common factor here would be the value with the variable x, because there's two lots of x here, one x here. So we could take one lot of x out, leaving us 2x plus 1 inside the brackets. And for the second bracket, notice that we could take a factor of 2 out. So if we take 2 out of here, we're left with 2x plus 1. So now, notice from here, what's inside the bracket is identical. So we could take we could factor out the 2x plus 1, leaving x and 2, positive x and positive 2. Therefore, our factors of the quadratic equation are 2x plus 1 and x plus 2. Now, as always, let's multiply out these, let's expand these two brackets and see if we get what we started off with. Okay, so to check, we have 2x multiplied by x, which gives us 2x squared. 2x multiplied by 2 gives us 4x. 1 multiplied by x gives us x. 1 multiplied by 2 gives us 2. Tidying this up, we get 2x squared. 4x plus x gives us 5x plus 2. Now we compare this with what we started off with. Yes, we do indeed get what we started off with. We indeed do get the quadratic equation we started off with. Therefore, our factorization is indeed correct. Okay, so that was method 1. So now let's look at how to factorize a quadratic equation or an expression when the first constant term is not 1. So this is a second method of how to factorize. Okay, so the steps involved are, first of all, is similar to similar to method 1. We multiply the first number and the second number together, and then write down the factors of the multiple. And then we need to find a pair of factors, step 2, which is actually same as method 1. We need to find a pair of factors that add and multiply to give this new multiple. So we go from step 1. And then step 3 is we put into brackets the first term, ax, inside brackets. Inside the brackets is the first term of the equation without the power, and the second term will be the second numbers from step 2. Okay, so check each bracket. If they have a common factor, then we can divide. It, and then step 5 is check if the second number of each bracket, when multiplied, gives us the original value c. Okay, so yeah, again, it sounds very complicated, but let's see it in action by an example. Okay, so example 8.08, factorize the following quadratic equation. I think this is one of the ones we've seen before. So we have 2x squared plus 5x plus 2 equals 0. So the first step, we need to find the factors of a times c. So in this case, a is 2, c is also 2. So 2 times 2 is 4. So the factors of 4 are 1, 2, 2, 4. And the second step is that we need to find two factors that add to give us the middle number, which is 5. So the two factors that add to give us 5 are 1 and 4. The third step tells us that we need to open two brackets, and we need to put the first term without the power inside both of the brackets. So we have 2x, 2x, and then we put the two factors in, 1 and 4. And we need to also check that are there any factors? If so, then take them out. So we notice in the first bracket there are no factors. In the second bracket there is a factor of 2. So we take the factor of 2 out, leaving us with x and x plus 2. Okay, so the first bracket stays as it is. The second bracket, when we take the factor out, it just leaves us with x plus 2. So we write that down. And okay, so I believe that's our solution. So we need to check, is this our solution? Has our quadratic equation been factorized correctly? So we multiply out the brackets. We have 2x multiplied by x gives us 2x squared. 2x multiplied by 2 gives us 4x. 1 multiplied by x gives us x. 1 multiplied by 2 gives us 2. Therefore, we have, just tidying this up, we have 2x squared plus 4x plus x plus 2, which equals 2x squared plus 5x plus 2, which is indeed the original equation, quadratic equation we started off with. Okay, not so bad.